Section 5.2 of your textbook describes the process of factoring trinomials of the type x squared plus bx plus c. Remember that to factor an expression means to write an equivalent expression that is a product. And the product is the result of a multiplication process. So we can see that factoring and multiplication are closely related to each other. In fact, factoring can be thought of as a sort of an undoing process or a reversing the process of multiplication that has already occurred. So in order to understand how to factor trinomials of this type, it's really important that you first understand how to multiply binomials. If you're already familiar with this process, at this point you can pause the video and try multiplying each of these 4 pairs of binomials. Then you can restart the video to see the solutions. To multiply the 2 binomials x plus 2 and x plus 4, remember that we'll start by first distributing the first term, x, from that first binomial to both terms, x and 4, of the second binomial. So first we have x times x, which is x squared. Then we have x times 4, which is 4x. Now we'll go back to that first binomial and distribute the second term through both terms of the second binomial. So first 2 times x is 2x, and then 2 times 4 is 8. Finally, we'll simplify that answer by combining the like terms. We have a 4x and a 2x, so those add up to 6x, giving us a final answer of x squared plus 6x plus 8. Following the same pattern, we can do these other multiplication problems a little bit more quickly. In the second case, we have first x times x, which is x squared, then x times negative 5, which is negative 5x, then negative 3 times x, which is negative 3x, and lastly, negative 3 times negative 5, which is positive 15. Combining the like terms, negative 5x and negative 3x, leads to the answer x squared minus 8x plus 15. In the third problem, we have the quantity x plus 8 times the quantity x minus 6. So first we have x squared, then negative 6x, then 8x, and then 8 times negative 6 would be negative 48. Combining the negative 6x and the positive 8x, we get positive 2x, and so we see the trinomial that we have for our answer. Lastly, x minus 8 times x plus 6, we would have x squared plus 6x minus 8x minus 48. Combining like terms in the middle of that expression, we get x squared minus 2x minus 48. Now let's look more closely at these problems and at their answers in order to understand how we can factor trinomials of this type x squared plus bx plus c. First, let's compare the constant terms in the binomials and their product to the answer, the trinomials that we resulted in. First case, we have 2 and 4 as the constant terms of our binomials. Remember, constant terms are the terms that don't contain variables. The product of 2 and 4 is 8. And notice that that shows up in the trinomial right at the end of the answer as the constant term in the trinomial. You can see this is true for all 4 examples. The product of the 2 constants in the binomials, negative 3 and negative 5, gives us the constant term of the trinomial, positive 15. Positive 8 times negative 6, again, gives us the constant of our trinomial, negative 48. Negative 8 times positive 6, negative 48. So we can summarize that by saying that the product of the constants in the binomials is equal to the constant in the trinomial. Let's consider a different question. What about the sum of the constant terms in the binomials? Well, in the first case, we have a 2 and a 4. Their sum is 6. Where does that show up in our trinomial? It's right here in the middle of the trinomial. Similarly, a negative 3 and a negative 5, the sum of those is negative 8, and there it is in the middle of the trinomial again. The sum of 8 and negative 6 is 2. The sum of negative 8 and 6 is negative 2. So it seems that the sum of those constant terms in the binomials always becomes the coefficient of x in the middle of the trinomial. Let's use these two observations we've made to help learn how to factor trinomials of the type x squared plus bx plus c. In order to do this factoring process, we're going to write a product of two binomials. The first term of each binomial will be x, and the second terms of the binomials have a product of c and a sum of b. That's just what we just noticed in the last slide. A product of c, that's the constant of the trinomial, and a sum of b, the coefficient of x in the trinomial. Let's do an example. Let's say we want to factor the trinomial x squared plus 10x plus 24. Well, we're going to factor it as the product of two binomials. The first term of each binomial should be x. That's how we obtain the x squared at the beginning of our trinomial, x times x. And then the constant terms should be providing a product of 24 and a sum of 10, right? Product of c, the constant in the trinomial, sum of b, the coefficient of x in the trinomial. So we're just trying to solve a little puzzle here. What two numbers multiply to give an answer of 24 and add to give an answer of 10? If you're unsure of the answer, if it doesn't jump out at you right away, the best way to start is by listing all the possible ways to make a product of 24 from two numbers. So let's do that. We could have 1 times 24, we could have 2 times 12, we could have 3 times 8, or we could have 4 times 6. All of those would give us products of 24. However, only one of them is using two numbers that give us a sum of 10. The first group of numbers would sum to 25. The second pair of numbers would sum to 14, 2 plus 12. The third would sum to 11, 3 plus 8. But the last one, 4 and 6, has a sum of 10. So those are the numbers we're really looking for. And so we can finish our factoring process by filling those in as the constants of our binomials. So we've factored the trinomial x squared plus 10x plus 24 into the product of the quantity x plus 4 times the quantity x plus 6. Let's go through some other examples a little bit more quickly, and then I want to look at some patterns that we can see from these examples. We're going to factor each polynomial the same way we just did that last one. So first, x squared plus 9x plus 14. We'll write two binomials. First term of each binomial will be x. In order to determine the correct constant terms, we want to look for two things, two numbers that have a product of 14, and then that have a sum of 9. Again, you could make a list or mentally make a list. Ways to get a product of 14 would be 1 times 14 or 2 times 7. Notice that 2 plus 7 is 9, so we're going to use those as our constants. And our answer is the quantity x plus 2 times the quantity x plus 7. Let's move over to example number 2, x squared minus 7x plus 12. Again, we'll write two binomials. The first term of each is x. And then we want two numbers that have a product of 12, but in this case we want a sum of negative 7. This is a little bit different than what we had before because of that negative sum. However, if we think of all the ways to make a product of 12, 1 times 12, 2 times 6, and 3 times 4, we'll notice right away that 3 times 4 seems to be a good choice because that would give us a sum of 7, right? We want a sum of negative 7. All we have to think about is making those two factors negative so that they would add up to a negative 7, but they would still multiply to give us positive 12, negative times a negative being positive. So we have x minus 3 and x minus 4 as our two binomials. What about example number 3? On example number 3, we again can start by making the first term of each binomial x. Now we actually have a product that is negative, not a sum that is negative, but a product of negative 40. And we want the sum to be positive 3. So let's think about product of negative 40. Well, in order to get a product that's negative, we can't have both factors be negative. What we need is one negative and one positive multiplied together, right? So we could have something like 1 times negative 40, or we could have negative 1 times positive 40. So we can sort of just switch the negative back and forth between the two factors there as we're making our list. If you keep making a list, you'll hopefully come up with 5 times 8 as being a good option. The reason is you could either have negative 5 times positive 8, which would give you a sum of 3, or you could have positive 5 times negative 8, which gives you a sum of negative 3. Now we wanted a sum of positive 3, so we're going to pick that first example. But I do want you to notice that switching the location of the negative sign on the factors just results in the sum changing from either positive or negative. So that 5 and 8 combination is really the key piece of information. And once we decide that we want to use 5 and 8 as our numbers, we just have to decide which one is negative, which one is positive, based on the fact that we want a sum of positive 3 for that middle term of our trinomial. So x minus 5 times x plus 8 is our answer. Number 4 is similar to number 3 in that we have, again, a negative product, negative 6. So we'll start with our two binomials. X is the first term for each. And we want a product of negative 6 here. But we want a sum of negative 1. Remember, there's a 1 as a coefficient in front of that x, even though it's not written. So for a product of negative 6, we could have 6 times negative 1, or we could have negative 6 times positive 1. But those will have sum of 5 or negative 5. That's not what we're looking for. What about 3 times negative 2, or negative 3 times positive 2? Well, there we can see we get sums of positive 1 or negative 1. That sounds better. Which one do we want? Well, we see a negative sign in our trinomial there, negative x. So we want the sum of negative 1, which means we're going to pick the 3 to be negative and the 2 to be positive. And we've correctly factored these 4 trinomials. Now let's summarize this a little bit and look at some patterns that are important. First, note that you can learn a lot from the sign of the constant in the trinomial. In these first two problems, the constant is positive. What that means is you'll need to either be multiplying two positive numbers together or two negative numbers together to get that positive result. How do you know whether you're multiplying two positives or two negatives? We simply look over to the middle term and determine whether it's positive or negative. Because two positive numbers would certainly have a positive sum, and two negative numbers would have a negative sum. Another way of saying that is, if the constant term is positive, the sign that goes in each of your binomials is determined, it's the same as the sign of the middle term from the trinomial. What about examples 3 and 4, where the constant term is negative? Well, with the constant term being negative, the only way to get a negative product is to multiply a negative number times a positive number. So notice that in both these answers, we have one factor, one binomial containing a negative constant number, and the other one containing a positive constant number. Negative, positive, negative, and positive. Now, how do we determine which one is negative or positive? Well, again, we can look at that middle term's sign. Since we want the positive middle term in example 3, we picked the larger absolute value factor, the 8, instead of the 5. We picked that 8 to be positive. Since we wanted a negative sum in problem 4, we picked the larger absolute value number, 3, to be negative, and we had the 2 be positive. To summarize all this, to factor a polynomial of the type x squared plus bx plus c, we're looking for a pair of factors of c, two numbers that have a product of c, but that have a sum of b. If c is positive, if that constant term is positive, then the factors have the same sign as b, as we saw from those first two examples. However, if c is negative, then one factor is positive and one factor is negative in both cases. The factor with the larger absolute value has the same sign as b. So, the larger absolute value is 8, that gets the positive sign. Over here, in the second example, the larger absolute value is negative 3, that's why it has a negative sign.